Sometimes you have what we call special systems. And so when you solve it, something weird happens. And so let's look at this example here. I'm going to solve with elimination. The same thing will happen for substitution, so I'm not really worried what method we use. But here, if I solve with elimination, I'm going to cancel out my x's. So I'm going to multiply the top one by 3, because then I'll get a positive 6x, which will cancel with the negative 6x. So I go through and I multiply through by 3, so I get 6x plus 3y equals 15. And then I go through the bottom and I get negative 6x minus 3y equals negative 15, just rewriting the bottom. And then I put these together. So then the 6x and the negative 6x cancel out, just like we thought. And then we go to the y's and we see that the positive 3y and the negative 3y also cancel out. So if I'm looking at the left-hand side of this equation, everything canceled out, which means I have the number 0 left over. And then on the right-hand side, I have 15 and minus 15. Those cancel out too, so I actually have 0 on the right-hand side. And so whether you're doing substitution or elimination, you're going to find that what happens is you get 0 equals 0, or maybe you'll get 5 equals 5, or 2 equals 2. It doesn't really matter what the number is, as long as it's an actual true statement. And since all of these numbers are equal to themselves, this is true. And so what's happening is, if we look at the picture of this, what we'll do is, if we had put this into slope-intercept form, we would see that we would have a line that looks like this. Well then, if I go to this one and graph it, I would see that I get the exact same line once again. And so what's happening is we have one line on top of the other line, so everything is a solution. They share every single point. Every point on one line is a point on the other line. And so what's happening is we have something called all solutions. Now this happens once in a while. And you can tell, without graphing, you can tell that it's all solutions when the x's and y's both disappear, and you actually get something that's true. Then you know it's all solutions. Okay, so let's look at another example. Okay, so here, let's say I cancel out the y's. They're smaller numbers, so it looks easier. They both go into 6, so I'm going to make them both equal to 6, only they're both positive, so I'll make the top one negative. So I need to multiply the top one by negative 3, so that I get a negative 6y. I multiply the bottom by 2, so I get a positive 6y. So when I multiply through by negative 3, I get 18x. Then I get negative 6y equals a negative 12. On the bottom, I multiply through by 2, so I get I get negative 18x plus 6y equals 24. So then I add them together, and the 18x and the minus 18x, those cancel out completely. The negative 6y and the positive 6y, those cancel out completely. And so once again, I've got my equal sign, and on my left side, everything canceled out, so I've got 0. On the right-hand side, I've got negative 12 plus 24. That gives me a positive 12. And so you'll see here that I actually have something that's not true. This cannot be equal. 0 does not equal 12. And so what's happening on the picture of this is I graph one of the lines, and let's say it gives me this picture. I graph the other line, it gives me this picture, and they're parallel, which means neither line is ever going to intersect. They will never have a point in common. And so I can say no solutions. And those are your special systems.